This tutorial provides information on solving stoichiometry solution problems. You will find that the examples provided in this tutorial will help to supplement the information that you learned in video lesson number 3. Our first example shows us a situation where we're told that we have barium nitrate reacting with aluminum sulfate. And from the information that's provided to us, we want to jot down underneath the reaction the information that we have. So in terms of the barium nitrate, it is given as 0.280 molar. And we're told to find the volume in milliliters. So volume in milliliters is our unknown. It then goes on to tell us that our aluminum sulfate is 0.350 molar. Okay, so in this case we have 2 concentrations, and we have 25 milliliters of it. So from the standpoint of concentration and volume, the aluminum sulfate is the one that you have both the concentration and the volume. And you want to keep in mind that when you're given concentration and volume, that is the key to where you start. So always start with the one that gives you the concentration and the volume. Taking the molarity of 0.350, we're going to rewrite that as moles per liter. And we're going to multiply molarity times volume. So in this case, our volume happens to be 25 milliliters. We're going to move our decimal point over 3 places to the left to convert that into liters. And again, from the format standpoint, we have molarity and we're multiplying by volume. When we do that, the volume unit cancels and it leaves us just with moles. And in this case, this is the aluminum sulfate. So then we have to introduce the mole ratio, and our equation does happen to be balanced. So we're going from aluminum sulfate to barium nitrate. So in that case, our mole ratio of the aluminum sulfate is 1, the barium nitrate is 3, which then converts us to the barium nitrate. Now, again, from the standpoint of the format, we took molarity times volume times the mole ratio. Now, this is the type of problem, since we want to find volume and we look at what cancels, moles of aluminum sulfate is canceled, we now are left with moles of barium nitrate. So the only other piece of information that we have, and I will circle that in purple, is the molarity of the barium nitrate. So if we take that molarity and we flip it, and by flipping it, we have our 0.28 moles on the bottom, the volume liters, moles per liter, flips to the top. That allows the moles of the barium nitrate to cancel, leaving you just with liters. Again, from the format standpoint, this is times the molarity flipped. So we'll perform our math on that. We're going to end up with a numerical value in liters. Move the decimal place over 3 places to the right to get ourselves back into milliliters, which is a term that if you were in the lab would be feasible because you could measure that out with a graduated cylinder. So that's one of the example problems as a tutorial that reinforces what you saw in the original notes. So here's our next example problem. And in this one, we are given molarity of HCl, okay, again, that's our concentration, and we're given a volume and a molarity of the sodium hydroxide. So I'd like you to think back to what we just talked about in the previous problem. In the case where you're given this type of information, we always want to start with the component that has the concentration and the volume, which in this case would be the sodium hydroxide. Checking our equation, we are balanced. Just like you saw in the previous problem, our goal is to get volume of the HCl. Now, it doesn't specify milliliters or liters because we're starting with the molarity volume terms. We are going to end up with liters, and then we can convert that over to milliliters. So the same exact format. And if you'd like to pause the video and try to do it on your own and then check yourself, go ahead and do that, because this is going to be very similar to what you just saw in the previous one. Molarity of our sodium hydroxide times the volume converted to liters. Liter term will cancel. Times the mole ratio, which in this particular case you're going from sodium hydroxide to HCl, is 1:1. Now, just like you saw in the previous one, the only other information that we have is the molarity of the HCl. We're going to take that, flip it. So the 0.496 moles ends up on the bottom. The volume ends up on top. So moles of sodium hydroxide cancels with this moles of sodium hydroxide. This unit happens to be moles of HCl. This is molarity of HCl, so those units cancel. You're left with liters. Perform the math, and then move the decimal place. And then identify the component part. So 32.6 milliliters of HCl. The last example problem in this tutorial is a little bit different. This one uses the balanced chemical equation, so we're set on that. But I'd like to point out to you that this one starts out with molarity and asking for milliliters, the same as what you've done before. Okay, so we can jot that down underneath our component part. Okay, we're again, volume in milliliters is our unknown, but we are given a gram amount of sodium carbonate, so 1.25 grams of sodium carbonate. So the format on this one's a little different. When you're starting with grams, so in this case we're starting with grams, our first step in this case is always to convert to moles. So we're taking our 1.25 grams of our sodium carbonate. From the periodic table, we would add up the molecular mass. In this case, it's 106 to convert to moles of sodium carbonate. Okay, so format-wise, to be consistent with what you saw on the previous lesson, in this case, when you have a mass, you are converting it to moles. Then we're going to insert the mole ratio. So in the mole ratio, we're going from sodium carbonate to HCl is 1:2. Okay, so mole ratio in terms of format. Okay, now we are in a position that's very, very similar to what you've seen on the previous two problems in this tutorial. What do we have left? We have molarity. We want to get to volume. So if you think about it, what do you want to do with that molarity? You want to flip it. So if you were thinking that, you were correct. And that will get us to volume. Okay, so then again, in terms of units canceling, grams, moles, this is moles of HCl. Okay, just for your reference, okay, this is the molarity flipped format. And perform the math. And 0.033 liters of HCl, so move that decimal point, 33.0 milliliters of HCl. I hope this tutorial was helpful. As you proceed with the problems, if you have any questions, please make sure that you let me know.